About equivalent expression. In our previous lesson, we talked about multiplicative relationships on using independent and dependent variables on a table. So let's review that. The graph shows the total amount Caitlin earns Y based upon the number of hours she works X. Write an equation to determine the amount Y Caitlin earns given the number of hours X she earns while working. So number of hours worked is X, total amount she earned is Y. So let's look at the table. And for this 1 hour work is $8. 2 hour work is $16. 3 hour work is $24. What is the relationship here? The relationship is multiplying by 8. But how do you write this as an equation? How do you say it with the letter x? 8x, so y is equal to 8x. In other words, the amount she earns is multiplying $8 for every hour. That is what this table is saying. So if you look at the graph, she makes, for every hour she works, it's increasing $8 per hour. That's the rate of change. So, next screen. So again, what was the equation? Y equal 8x. And is this additive or multiplicative? Multiplicative. Because if we look at a table, we had to multiply. In a relationship, we had to multiply to find the answer. So today we're going to be relearning what is an expression. An expression is like a math sentence without the equal sign. There's no value to it. So for example, the expression for this is just 4x minus 7. An expression could be 2 plus 7. An expression could be 5 squared plus 8. So we have no value. So we don't know what the value is. We're just writing a sentence. So an expression has numbers, symbols, and operations that are grouped together. So there are many, many different ways to show multiplication as an expression. These are several ways. 3 times 5, that's what you learn in elementary school in 3rd grade. 3 group parentheses 5 are 3 groups of 5, which is the same thing. These two mean the same thing. 3 multiplication dot 5, and 5 plus 5 plus 5. All of these mean the same thing. They will all give you the value of 15. So if I ask you to write it as an equation, you will all set this to an equal to 15. Because an equation is a math sentence with an equal sign. An expression is just the math sentence. Let me erase this. So can you name some equivalent expression for 5 parentheses negative 4? So you can say 5 times negative 4. That's the same thing. 5 groups of negative 4. 5 multiplication dot negative 4. And then you can also say 5 groups of negative 4. So you can write negative 4 plus negative 4 plus negative 4 plus negative 4 plus negative 4. And then you can write it in word form. There are 5 groups of negative 4. So these are all mean the same thing. They're all written in the same way. So, for example, if you ever see a question like this, 2 groups of 5 is 10 plus 3 is 13. So this means multiplication. This is a form of multiplication. It could mean 2x5, 2 multiplication dot 5, 2 groups of 5, 2 of 5 plus 5, and 2 groups of 5. So, in this one, what we're going to be doing is we're going to be writing expressions, drawing pictures, and seeing if they are equivalent. So we're going to do it mostly today in picture form, pictorial forms. Alan saw movies on Friday and Saturday. So on Friday, he saw 3 movies. On Saturday, he saw 3 movies also. So can you write an addition and a multiplication expression to show the total number of movies that Alan saw? So how many movies did he see total? 3 plus 3 will be 6. So he saw 3 plus 3. What's another way to write that using multiplication? You can write it as 2 groups of 3. You can write it as 2 times 3. You can write it as 2x, like that one. And that's it. Let me go back to my previous example. Oh, yeah, and that's it. Those are the three ones because the other one is more of a words. This is perfect. So the total number of movies you saw was 6, but how would you express that as an addition? 3 plus 3. That's how you would find it. How would you write it as multiplication? 2 groups of 3, 2 times 3, 2 times 3. Next example. Let's take it a step further. Isa and Rana are working together on their math homework. Isa says that 3 groups of 5 plus 3 is equivalent to 3 groups of 5 plus 3. Ron says they are not equivalent. Sketch each expression to show who is correct. So, I predict Ron is correct. I don't think they're equivalent. So we're going to draw pictures to show this. So Isa said there are 3, so Isa is this one. So it's 3 groups of 5 plus 3. So this shows 5 and 3. This also shows 5 and 3. This also shows 5 and 3. She says there are 3 groups of it. 3 groups of 5 and 3. Ron, on the other hand, said his problem is this. 3 groups of 5 plus 3. So we have 3 groups of 5, 3 groups of 5, 3 groups of 5, and just a 3. Are these pictures equivalent? Do they look the same to you? Well, first of all, there are 3 groups of 5 and 3 groups of 3. This one has only 3 groups of 5 and just a 3 by itself. So no, they are not equivalent. If you had solved it, because some of you may look at this and it's like, why not just solve it? Fine. Would you learn about order operation? You do the grouping symbol first. 5 plus 3 is 8. What's 3 groups of 8? 24. Next one? What's 3 groups of 5? 15. 15 plus 3 is 18. So are they equivalent? No, they are not equivalent. So you can either do it through pictorial way or you can do it through solving the answer. I like solving it to get that. So no, they are not equivalent. Next one. Eli made 3 baskets on Tuesday and 3 baskets on Saturday. Maria made 5 baskets on Tuesday and 5 baskets on Saturday. Write an equivalent expression to the pictorial model. So on Tuesday, they have 3 baskets and 5 baskets. On Saturday, they have 3 baskets and 5 baskets. How can I write this as an expression, a mathematical expression using numbers and operation? Well, how many groups of this do you see? I see group 1. I see a second group. So there are 2 groups. 2 groups of what? I see a group that has 3 plus 5. Then I see a second group that has 3 plus 5. And this is the answer. So there are 2 groups of 3 plus 5. And that's how you write. Next one. By the way, you could also have written it this way. There's 2 groups of 3 baskets plus there are 2 groups of 5 baskets. This is another one. But we are going to be talking about this when we talk about distributive properties. We're not there yet. So right now I'm just focusing on the first one. There's 2 groups of 3 plus 5. There are 3 6th grade classrooms. Each classroom has 15 student chairs, 3 computer chairs, 1 teacher chair. Sketch a pictorial model. Now write an equivalent expression to a pictorial model. So there are 3 classes. Class 1, Class 2, and Class 3. In the first class, they have 15 student chairs, 3 computer chairs, and 1 teacher chair. In the second classroom, they have 15, 3, and 1. 15 student, 3 computer, 1 teacher. In classroom 3, they have 15, 3, 1. So how can I write this as an equivalent expression? How can I write this as an expression using numbers and operations? Well, first of all, how many groups are there here? There are 3 groups. And each group consists of what? A 15 plus a 3 plus a 1. And that is the answer. There's 3 groups of 15 plus 3 plus 1. Another way you could have written it is this way. Again, we're not going to learn this until we learn distributive property. This is a precursor to get you ready for it. But I see 3 groups of 15 plus 3 groups of 3 plus 3 groups of 1. Both of these are a great answer. I don't care which one you put down. So there's 3 groups of 15 plus 3 plus 1, or 3 groups of 15, 3 groups of 3, and 3 groups of 1. Let's go to our next statement. Now look at the following expression. Are these equivalent? You can either use words, numbers, or pictures. First of all, I'm going to do it with pictures. Then I'm going to go back and do it with numbers. So let's do the first one. You have 5 groups of 3. And then you have a 10. The second one says you have 5 groups of 3 with a 10. So you have 3, 10, 3, 10, 3, 10, 3, 10, 3, 10. The third one says you have a 3, you have another 3, you have 3 groups of 3 plus, and what is 2 times 5 going to be? 10. So are all these pictures equivalent? Let's look at it. In this picture, I see 5 groups of 3. This one has 5 groups of 3, but it has 5 groups of 10. But this only has 1 10. So the answer will probably be no. And this one has, 5 groups of 3 and only 1 10. So which one does not match the picture? This does not match the picture. If this had been something differently, they would have been equivalent. So that's one way you could have done it with pictures. What if you don't want to draw a picture? What do you like to answer it? So let's answer this. What's 5 groups of 3? Again, order operation. You do the grouping symbol, exponent, multiplication, division from left to right, adding, subtracting from left to right. So I do the multiplying, that's 15, plus 10 is 25. Do the grouping symbol first, that's 13. 5 groups of 13 is 65. First of all, you can stop right now. They're not going to be equivalent, but let's keep on answering. We do the grouping symbol first, that's 10. Then you do the multiplication, that's 9. Then you add from left to right. 3 plus 3 is 6, plus 9 is 15, plus 10 is 25. So are all these equivalent? No. Again, this does not match. So last but not least, now, given the pictorial model, can you write it in its expression now? So the first one shows 4 groups of, and each group has a 5 plus a 2. So it's 4 groups of 5 plus 2. Or you could have done it this way. There's 4 groups of 5 plus 4 groups of 2. Either one would have been acceptable. Again, we're not going to learn the second way until we go to distributive property. Next one. I see a 4 plus a 5 plus a 2. So it's one group of 4 plus 5 plus 2. Or you could just say 4 with a 5 with a 2. Next one. What do you see here? I see a 5 plus a 2 plus a 5 plus a 2. One group of it. Or you could say, I see 2 groups of 5 plus 2 groups of 2. This one, what do you see in this one? I see 4 groups of the same thing. Each group has a 4 plus a 5 plus a 2. Another way I can say, I see 4 groups of 4, 4 groups of 5, 4 groups of 2. Many ways you can see this. And last but not least, again, this is something you'll be seeing in algebra. We're not going to be learning this until you go to algebra, or for some of you, it'll be 8th grade math. So in this question, which of the following, so this, what we've been doing right now is very more 6th grade, just using numbers. But otherwise, you could be using variables or letters with numbers. So in this one, which one, what do you see here? Before I even look at the answer choices, I see 3 groups of the same thing. I see 3 groups with a 2 are 1 plus 1 is 2 plus an x. That's what I see. I see 3 groups of a 2 with an x. Let's see. Ooh, I think it's C right now. And then, if you multiply out, what's the final answer? How many 1s do you have? 6 of them. How many x's do you have? 3 of them. That's why C is the answer. Or another way you could say is I see 3 groups of 1 plus 3 groups of x's. Wait, stop. I see 6 groups of 1s plus 3 groups of x. Is that the same thing as this one? It is. 6 groups of 1 is 6. 3 groups of x is 3x. So what we have been learning here is putting groups together, writing equivalent expression. Given different types of numbers, can you group them together and show me different ways to write it as equivalent expression?